In the last video, I finished by saying that quantum mechanics needs complex numbers. In these and the following videos, I'll expand on the topics covered on the last one: states, measurements, and time evolutions. Now we'll start with quantum states. So if you didn't watch it, make sure to check it out. Let's go back to the electron example. Its spin can have two values, up or down, that can be represented as vectors, and they are vectors in a complex vector space. There are some mathematical requirements for this complex vector space. However, for a system with a single quantum object that can take on two values, it is enough to consider our space to be C2. The two basic quantum states are represented in Dirac notation, also called bracket notation, as 0 and 1. They are the vectors with coordinates 1, 0 and 0, 1, but they can also be written as column vectors using matrix representation. Vectors 0 and 1 form a basis for C2. That means that every vector in the space can be written as a linear combination of these two using complex coefficients. And any state with non-zero coefficients is said to be in a superposition of the states 0 and 1. But there are two conditions we put on the coefficients. The first is that the modulus of alpha squared plus the modulus of beta squared must be 1, because they represent the probabilities of measuring 0 and 1 respectively. And this has the pleasant consequence that psi becomes a unit vector. The second condition is about complex numbers with modulus 1. If we have such a number, it can be written as a complex exponential, and if we multiply vector psi by it, we get a new vector, but we consider the states to be equivalent. The video about measurements will make it more apparent why we want this condition. After all this theory, let's look at an example of two particular states in superposition. They are denoted by plus and minus, and the only difference between them is the sign associated with the second coefficient. Since that's the only difference, both states have a 50% chance of measuring either 0 or 1. That is all for this video. In the next one, I'll show the utility of using bracket notation.